Assalamualaikum warahmatullahi wabarakatuh. My name is KHIR 24 DKM 31F1015. Today me and my group will present about differentiation. What is differentiation? On Isaac Newton's day, one of the biggest problems was poor navigation at sea. Calculus helped improve navigation, less reliance on stars. Before calculus was developed, the stars were vital for navigation. Shipwrecks occurred because the ship was not where the captain thought it should be. There was not a good enough understanding of how Earth, stars, planets move with respect to each other. So, calculus, differentiation and integration was developed to improve this understanding. Differentiation and integration can help us solve many problems in this world. And now, I'm going to introduce you guys about application of differentiation. Differentiation and integration can help us solve many types of real-world problems. In calculus, differentiation is one of the two important concepts apart from integration. Differentiation is a process in math where we find the instantaneous rate of change in function based on one of its variables. This section of mathematics helps us to improve the construction, especially we design a particular building, road service, etc. In fact, this knowledge will be beneficial when you analyze the most constructive method for a particular work that leads toward a lesser cost while producing the most effective outcomes. This form of application can be used not only in construction field but also in any type of production. And I'm going to introduce you guys on the few formula for differentiation. The first one is power rule, second one is chain rule, the third one is sum rule, and product rule, the last one. There are also a few rules and that's called derivative of a constant and derivative of a constant multiplied with functions.
Now, let's see how this knowledge is applied when designing something cost effective. For an example, if we assume that we need to construct a water supply plan to distribute water for 3 cities, and the 3 cities are A, B, and C. When cities are located as follows, where distance between AB and AC are exactly the same, we need to identify the most suitable location to construct it, which has the shortest length of supply lines. For the geometry of these 3 cities, we can decide the proposed length should be decided. From the geometry of 3 cities, we can decide the proposal plan should be somewhere inside the triangle and vertically going through city A and midpoint of BC. We will name the location of plan as D. Now, measure the required length of supply line regarding the above figure. Required length of supply line L equal to Z plus 2Y. Let's convert this equation as follows.
For the equation, Z is equals 16 minus x, y is equals square root x squared plus 6 squared, L is equals 16 minus x plus 2 multiplied by square root x squared plus 6 squared. Now, let's differentiate above equation as L is shortest. dl over dx equals d16 minus x plus 2 multiplied by square root x squared plus 6 squared over dx. dl equals dx equals d16 over dx minus dx over dx plus 2 d square root x squared plus 6 squared over dx. Next, dl over dx is equals 0 minus 1 plus 2 multiplied by 2x over 2 square root x squared plus 6 squared. Next, dl over dx equals 2x minus square root x squared plus 6 squared over square root x squared plus 6 squared. Next, dl over dx squared equals 2x minus square root x squared plus 6 squared over square root x squared plus 6 squared multiplied by 2x plus square root x squared plus 6 squared over 2x plus square root x squared plus 6 squared. Next, dl over dx squared equals plus 4x squared minus x squared plus 6 squared over square root x squared plus 6 squared multiplied by 2x plus square root x squared plus 6 squared. Next, dl over dx equals 3x squared minus 6 squared over square root x squared plus 6 squared multiplied by 2x plus square root x squared plus 6 squared. And the answer, dl over dx equals 3x squared minus square root 12 squared over square root x squared plus 6 squared multiplied by 2x plus square root x squared plus 6 squared. Now, if dl over dx equals 0, where x equals square root 12, hence the water supply plant D should be located on the vertical line from the city A by a distance of 16 minus x kilometer. Now, equals 16 minus x, next equals 16 minus square root 12, then 2 bracket at square root 3 bracket kilometer. Say square root 3 equals 1.73. Therefore, plant should be located on the vertical line from the A by a distance of 12.54 km. And that's how you use the application of differentiation in construction. So in conclusion, differentiation was really important in industry and construction. Without differentiation, there might be a lot of error can be occurred when the process on making building or machine in progress. So that's it from me and my group. Thank you very much. Bye.